Hello and welcome to a video that will explain the basics of multiplying matrices. So let's first start off with talking about how you multiply matrices, because multiplying matrices is a little more complex than adding matrices together. So first, let's start talking about whether the multiplication is possible, because there are certain matrices that you cannot multiply together. And let's talk about, if multiplying the matrices is possible, the size or the order of the answer of the product, what that's going to look like. So this first matrix here is a 2 by 2 matrix. There are 2 rows and 2 columns. And the second matrix here is also a 2 by 2 matrix. So in order for matrix multiplication to be defined, the number of columns in the first matrix and the number of rows in the second matrix must be the same. So if those two values are the same, this matrix multiplication is going to be possible. And if I want to know the size or the order of the answer, so in other words, I'm going to multiply these two matrices together and get back a third matrix. So the size or the order of the third matrix is going to be a 2 by 2. So those two, the number of rows in the first matrix and the number of columns in the second matrix. That's going to be the order of the product. So I know that when I multiply these two matrices together, I'm going to get a third matrix that is going to be a 2 by 2 matrix. So I'm just going to set that up right here. But then I need to figure out how the matrix multiplication actually works. Okay, so I'm going to need a bunch of space on this slide, so I'm going to go ahead and erase this. So when you multiply matrices, this works much different than adding. What you're going to do is you're going to take an entire row, so I'm going to take the entire first row of this matrix, and you match up rows from the first matrix with columns in the second matrix. So I'm going to match up this first row with this first column. Now that is going to produce a single number, and I'm going to tell you exactly how to produce that number momentarily. And that number is going to go in the spot right here. It's going to go in the first row in the first column. So if I'm taking the first row, row number 1 in the first matrix, and I'm going to multiply that by column number 1 in the second matrix, the result is going to go in the first row in the first column, so right here. Now how does the multiplication work? What happens is that you're going to sort of match up the entries. So I'm going to do this first number here, this 2 times -1, and then I'm going to add that to -3 times 6. So it's sort of like I'm matching up this row and this column. So I'm taking this first number, this 2, match it up with this -1, this -3, matching that up with the 6. So you're multiplying all the numbers that sort of match up together, and then you're adding all those results together, and that's going to produce a single number. So this is going to give me -2 plus -18 is -20, and that result goes in the first row and the first column. And now I'm just going to repeat that process until the multiplication is completed. So if I take the second row and the first column and do the same process, the result is going to go in the second row in the first column right here. So second row, first column, and the result goes in the second row in the first column. So let's match up. It's going to be 1 times -1 plus 5 times 6. So that's -1 plus 30 is 29. So this will go right here. Great, back to the matrix here. So now I'm going to take the first row and the second column, and that result is going to go right here in the first row in the second column. So if I match everything up, it's going to be 2 times 7 plus negative 3 times 0. And that gives me 14 plus 0, which is 14. And that's going to go in the first row, the second column. And then last but not least, I'm going to take the second row and the second column, and the result is going to go in the second row and the second column. 1 times 7 plus 5 times 0, and the result is 7 plus 0, which is 7. So I've successfully multiplied these two matrices together, and this is my result. And I sort of systematically organized my work underneath. So let's look at an example where we're not multiplying two square matrices together, two matrices that have the same number of rows and columns. So here's a good example. We've got a 3 by 2 matrix. It's 3 rows and 2 columns. We're going to multiply that by a 2 by 3 matrix. There's 2 rows and 3 columns in the second matrix. So since the number of columns for the first matrix and the number of rows for the second matrix match, so that means that the multiplication is defined. So we're good to go. We can actually multiply these matrices together. We don't get no solution. And the result, the order of the product, is going to be 3 by 3. So the answer here is actually going to be a 3 by 3 matrix. So I'm going to sketch out a little bit of a bigger matrix there. And we're going to proceed in a similar fashion. We're going to match up rows from the first matrix. I'm going to take like this first row here and match that up with columns in the second matrix. So if I take the first row and the first column, that result, once I do that multiplication, is going to go right up here in the first row and the first column. So write that out. It's going to be 2 times negative 1 plus 1.5 times 3. So that's going to give me negative 2 plus 4.5 is going to give me a 2.5. And that's going to go in the first row, in the first column. Great, now back to my matrices. I'm going to stick with just using the first row here. So now I'm going to move on to sort of setting up the first row with the second column, and my result is going to go in the first row in the second column. Now let's match up my entries. I've got 2 times negative 1 plus 1.5 times negative 7. Ooh, and I don't have my calculator on me, so I hope you're checking the math as you watch this video. So this is going to be negative 2, and 1.5 times negative 7 is going to be negative 10.5, so this is going to be in total negative 12.5. Make sure you're checking that for me. Then I'm going to move along, then I'm going to take the first row, match that up with the third column, and the result is going to go in the first row, the third column. I've got 2 times 5 plus 1.5 times 4. So that gives me 10 plus 6 is 16. So I just experienced a slight technical glitch. So I just had to quick rewrite the matrix here. So I've written in all of the rest of the entries. So why don't you go through now, maybe pause the video, and make sure you know how to fill in the rest of the entries. So we'd be taking the second row here, and then you're going to work through all of the columns one by one. So if we do the second row in the first column, multiply the corresponding entries, add them together, that's going to go in the second row, the first column. And then if we did the second row in the second column, then that result would be that negative 6.5 there, and so on and so on and so on. So why don't you really quickly finish that multiplication, make sure you agree with all these entries that you get this answer, and if not, call over your teacher and they can sort of help you with where you are stuck before you move on in the video. Great, so the last thing that we want to look at is if matrix multiplication is commutative. So this example here, in the first slide, we did this exact matrix multiplication, but we did it sort of in reverse order. We did the 2, 1, negative 3, 5 matrix times the negative 1, 6, 7, 0 matrix. So I flipped the order here. Excuse me. And we want to figure out if matrix multiplication is commutative. So in other words, with numbers, multiplication is commutative. So just a quick refresher on that. 2 times 3 is 6, but 3 times 2 is still 6. The order in which I multiply numbers, if I switch the ordering, that does not change the result. So what we want to figure out here is the same true with matrices? So we know we're going to get a 2 by 2 answer, but the question is this the exact same 2 by 2 that we got on the first slide? So let's work it out real quick. We're going to take the first row, the first column, negative 1 times 2 plus 7 times 1 is 5. And we're going to take the first row and the second column. Negative 1 times negative 3 is 3, plus 35 is 38. That goes in the first row and the second column. Then we're going to switch over here and start using the second row. Do the second row in the first column. 6 times 2 plus 0 times 1. That's 12. And now we'll do the second row and the second column to finish the multiplication. Negative 18 plus 0 is negative 18. So that's what we get when we multiply these two matrices together in that order, 5, 12, 38, negative 18. But notice that's not the matrix that we got in the first example. So the order in which you multiply matrices does matter. Matrix multiplication is not commutative. So the answer to that question, is matrix multiplication commutative? No, it is not. So matrices are a little bit more complicated than numbers. You have to be really careful when you're performing your operations, but I know you're going to do great, and good luck.